Well, welcome back. I hope you got to meet somebody new. I met a couple of new people in my room, which was awesome. As a reminder, we are recording this webinar. Please don't interrupt the speaker during the webinar, but you are welcome to put questions in the chat. And then at the end, we will also have a Q&A either via the chat if that's what you're more comfortable with, or you can raise your hand. I'm really excited today that our speaker is Dr. Vicki Ferrini from Lamont-Doherty. I have been trying to get her on her calendar for quite some time, and she just told me we are the first of 4 talks she's giving this week. So I'm lucky that we get her fresh and new, and she's going to be talking to us about unlocking the seafloor via ocean mapping. And so, Vicki, I'm going to stop sharing, and I'm going to hand it over to you.
Awesome, thank you. Let's see if I can share back and put it in full screen. There we go. All right, well, thank you for having me, and thanks for the opportunity, and great to see a lot of familiar faces and a lot of new faces. Um, the breakout session I was saying was a little bit challenging because I kept thinking about all the things I could have put in my slides. But what I'm going to do is give you a bit of an overview really on the global perspective of where we're at with ocean mapping, and talk largely about Seabed 2030, which is a very exciting international initiative. There's a bunch of data systems listed here on my opening slide to give you a sense of some of the projects I work on. And part of why I wanted to make sure that you saw that is if you are familiar with these systems and have questions or exciting feedback or pain points, we love to hear from people. So please reach out about these systems. But also, I've started describing myself as a bit of a data encyclopedia. I happen to know a lot about where to find data. So even if it's not in one of the systems that we work with, I often know how to help people navigate to data resources that are out there. So um, those of us in the data space love to hear from people. So please do reach out at any time. All right, let's see if I can, there we go. All right, so why is global ocean floor mapping important? I like to start with this just to give really the big context and to draw our attention a little bit to the sense of different scales over which ocean mapping is important. So from the sort of fine scale and really impactful world of nautical charts and safety of navigation, out into the deep ocean where we're still trying to understand basic Earth processes and really complete the map of the ocean floor, and lots of applied and research things in between. Really, ocean floor mapping is essential to much of what we do, if not all of what we do in the ocean space. And it's remarkable when we think about how little of the ocean remains unmapped. Gotta figure out my clicking here. It's a little bit sluggish. Here we go. All right, so GEBCO, the General Bathymetric Chart of the Oceans, was started over 120 years ago by a few men sitting around a table in Monaco who recognized at that point, and also there was recognition prior to them sitting around this table, that the work of understanding and in particular mapping the ocean floor really required collaboration and cooperation across the planet. Today, GEBCO is still very active. It operates under the joint auspices of the International Hydrographic Organization, which is based in Monaco, and the Intergovernmental Oceanographic Commission of UNESCO. And so the objective of GEBCO is to provide the most authoritative, publicly available bathymetry of the world's ocean, which is, I hope you'll come to see, a pretty significant task. It's amazing how slow the clicking is. There we go. Okay, so GEBCO products that are available to the world include gridded bathymetric data. Prior to the creation of Seabed 2030, which I'll tell you a lot about, this product was at 30 arcsecond resolution, which is somewhere around 800 meters. Since 2019, we have been releasing this grid at 15 arcsecond resolution, which is on the order of 400-meter resolution. We are working to make higher resolution data available in particular areas of the ocean. In addition to this gridded data set, we have web map services that can be integrated into web applications. There is the Gazetteer of Undersea Feature Names. that is a very exciting international effort to have commonly used names across the ocean floor. There's grid viewing software, there's printable maps, and the IHO IOC cookbook is a recipe guide for how to work with bathymetry data. You can find these products on the JEBCO website, and you can get to the grid through the Seabed 2030 webpage as well. So when we think about the planet and how much of the ocean is mapped, frequently people are shocked to learn how little of the ocean is mapped. So with maps such as this, where we're using predicted bathymetry to fill in the background, it looks like the ocean is fully mapped. But of course, that's not the case. And as of last year's release of the JEBCO grid, if we overlay on this a sort of blacked out layer that indicates where we don't have measurements, you'll see that there are huge areas that are unmapped. And as of last year, only 26% of the ocean is basically supported by direct observations of depth. So the rest of this is predicted. What this means, of course, is that less than half of our planet has been mapped when you do the math. So it's a pretty remarkable amount of our planet that remains hidden from us. So what is Seabed 2030? This is a collaborative effort. The Nippon Foundation and JEBCO have come together to establish this project as a collaborative initiative to inspire the complete mapping of the world ocean by 2030 and to compile all available bathymetric data into the JEBCO grid. And the motivation for this is really to empower the world to make policy decisions, to use the ocean sustainably, and to undertake scientific research that's informed by a detailed understanding of the global ocean floor. So why is this important? Seabed 2030 is really working as an accelerator for JEBCO. When the project started, only 6% of the global ocean floor had been mapped. As we've proceeded through the project, we've increased pretty significantly up to 26%. These bars on the bottom are the annual releases of JEBCO. But I think one of the more important angles to why this is an important project is, again, underscoring that bathymetry is an essential ocean observation. This data has broad use and value. And to do this, we really have to come together as an international community and cooperate and coordinate, especially given the magnitude of the work that's left to be done. And also, of course, as I'm sure we all know, the ocean processes that are of interest to us in the science community and also in the regulatory and policy space extend beyond territorial waters. So we really need this holistic view. We're also fortunate, the timing is great, that this is happening in parallel with the UN Decade of Ocean Science for Sustainable Development. We can actually map to each of these decade challenges why ocean mapping is important. Sorry for the pun there with mapping, but it's really a fundamental data type that has broad use. And so having the Ocean Decade in parallel to Seabed 2030 is a great opportunity for us to build momentum. So what do we mean by 100% mapped within the context of Seabed 2030? This map that we published in 2018 really lays out the framework that we are using to achieve this goal. And so we basically divided the ocean into different zones based on water depth and based on ship-based multi-beam mapping systems, because that gives us something reasonable to work with. I think we would all love to see better than 100-meter resolution everywhere. But in terms of being able to make tangible steps toward our goal, we have the shallower water from 0 out to 1,500 meters depth. We are aspiring for one sounding every 100 meters or a 100-meter grid. In the slightly deeper water from 1,500 to 3,000 meters depth, we're going for 200 meters. In the 3,000 to 5,750 meter depth, so this is the vast majority of the ocean, we're aiming for roughly 400 meter resolution and soundings at that distance. And that is consistent with the product that we have been releasing for the past several years. So this multiple resolution product that we are working toward will be in the shallower waters. We'll have higher resolution available wherever the data that's come to us can support that. So this really is the canvas of the ocean floor. It's the broad general shape of the seafloor. We've done some benefits analysis to try to make the business case and the impact case for why seabed mapping is important in a variety of different spaces. These are resources that are available on the Seabed 2030 website. But the way that we're trying to do this really massive project is in a regional way. So we've divided the globe up into 4 regions. Each region has a center that sort of shepherds the work that's being done. Each of the regional each of the regional centers is meant to engage with stakeholders, build upon existing efforts. We don't want to do things redundantly. We really want to be as efficient as we can. We need to build capacity. We, of course, assemble regional data products, and we identify where data gaps are. The regional pieces that we construct go to the global center, which then builds the global products that are made available to the world. We also have a long-term archive. It's recognized as the International Hydrographic Organization's Data Center for Digital Bathymetry. It happens to be operated here in the US out of NOAA's National Center for Environmental Information out in Boulder, Colorado, which serves as the US archive for bathymetry data as well. So we're really trying to have a unified approach across the globe with regional hubs sort of leading the charge. The Atlantic and Indian Ocean region is the region that my group here at Lamont is responsible for. This map shows the extent of it. The total area is quite large. It makes up roughly 39% of the global ocean, and a big portion of it is covered by EEZs. It's also very exciting and challenging that this area is bounded by over 100 countries on 6 continents. So there are a lot of stakeholders for us to work with. But it's a very exciting opportunity and challenge for us to figure out ways to engage people all around the world, to understand what's happening, what the needs are, and how we can try to work together to solve mutually beneficial, come to mutually beneficial outcomes that really solve problems we're all trying to confront. So capacity building is a huge part of this. We had the pandemic, which slowed down a little bit of this and made us do things somewhat virtually for quite a while. But since the pandemic, we've been able to do a lot of in-person capacity building, where we've held workshops, both to help the community understand the data resources and the tools that are out there. But I think even more importantly, from my perspective, for us to understand what people need, how we can help them to work with the data that they do have available and get it to a point that they can do what they need to do with it and also contribute it into this global compilation. So we've had workshops all around the region. You can see some of the pictures of different groups here. We're leveraging also the network of alumni from a training program that has been funded by the Nippon Foundation for about 20 years now. It's held at the University of New Hampshire Center for Coastal and Ocean Mapping, and the alumni of this training program are distributed all over the world and are becoming leaders in their spaces, in their countries, and are a huge part of this network that we are able to activate to help catalyze the momentum that we are trying to achieve here. So it's really a very exciting and rewarding opportunity to work with people all around the world. So one of the things that we really focus a lot on here in our center is cultivating a culture of data and knowledge sharing. For those of you who know me, you know that's what I've been doing with my career all along with various tools and projects, but really prioritizing collaborations, empowering these communities, again, pursuing mutually beneficial goals, listening and understanding what's happening, what the needs are, and trying to do our best to meet those needs. Really encouraging data sharing, but not demanding it, trying to understand where that common space of where people are comfortable sharing data, understanding what the limitations are, and trying to figure out how to work within those restrictions. Contributing the scientific and technical expertise that not only we have in our center, but also that we have in our networks, trying to match people up and try to help solve problems. We've done things like develop custom web interfaces like the one that's in the top image here, It looks super crazy busy with lots of polygons and lines, and all of that represents different data types that are information about them are made available through different web services that all seem robust and they are certainly interoperable, but they don't all necessarily give us the same information. So we're trying to understand how to break through these bottlenecks and how to make these tools more understandable, more usable, and actually more actionable. So how can people use this information to plan, new surveys, new activities, or to seek collaborations with data holders that they maybe didn't know had nearby data of interest and whatnot. We, as I said, have workshops and webinars. We've started doing virtual office hours. And we really work to make every kind of data that we can get access to integrated and transformed into high quality data products. So this really made me laugh last night, all depths considered. I thought I was so clever, but really we're using every kind of data that we can. And this schematic does a nice job, this cartoon does a nice job of demonstrating the variety of sensors and platforms. So it could be multi-beam sonars on small boats or ships. It could be multi-beam sonars on autonomous underwater vehicles or on unmanned surface vehicles, on crewed surface vehicles. It could be optical imaging techniques through aircraft and drones. It could be crowdsourced bathymetry from just navigational sonars on small, like my little recreational fishing boat. I could be capturing data from that. Um, we're certainly also using data from satellites, whether it's to fill in the gaps between measured observations or to actually do imaging through the water in shallow, clear water areas to get an understanding of the bathymetry itself. And what I love most about this diagram is that there's a pelican there, right? So a bird is listed, is shown, and it's not labeled. But in fact, we have received data, and a turtle. We have received data from turtles and from birds. So that people are putting pressure sensors on animals and they're descending to the seafloor and we're getting those data, and that's even data that we have integrated. So really everything that we can get our hands on, even digitized contours from old charts, we're working with that to integrate it into this map to try to fill as many of those grid cells as we possibly can. So just to give you a sense of what this kind of looks like, zooming in here on the Caribbean, this is last year's compilation of measured bathymetry from the region. You can go explore this in a story map if you're interested. But what we basically, I'll show you here how we bring different data sets together. So this is the extent of multi-beam data that we have integrated. Um, there's quite a bit. There's still more that's in the archives that we haven't yet processed and integrated, but this is by far the most dominant data type in the global ocean maps. Of course, ship-based multi-beam data and the resolutions we're going for, this is all still pretty coarse when we think about sampling on the seafloor, but nevertheless, very important. Moving on to single beam. So we're still getting a sounding under the boat as it's moving along, but you can see even in this context, we've zoomed in a bit. These are tiny little lines of data. They're not typically very well constrained. Sometimes in areas like the Great Barrier Reef, there's a lot of single beam collected from crowdsourced bathymetry. You can actually create a pretty good image or of what the shape of the seafloor looks like, a pretty good model. But with these sparse lines, there's data, but it's not particularly or not super helpful or rich. Here's a pretty well-known data set from the Gulf that was derived from seismic data that fills in a huge area of coverage for us. Electronic nautical chart sounding. So these are little discrete measurements on charts. Again, just little dots, but we bring these in as well. And then satellite-derived bathymetry. This is an example with optical techniques looking through the water to measure bathymetry. It's then ground truthed with some small boat operations. We've done a lot of, we've received a lot of this kind of data, and we've worked very closely with different groups really trying to get this technique into the hands of more people around the world so that they can do this kind of data extraction or compilation themselves, which has been really great. Another kind of satellite-derived bathymetry is actually wave kinematic. So looking at how the waves are breaking and being able to back out of that what the depth is likely to be. So this is a very useful technique for shallow water where it would take a really, really long time to go back and forth with a multibeam, but we can get a pretty large area covered optically. Another optical technique is LiDAR, of course, also pretty limited to shallow water, but we have quite a few little areas of that kind of data. So what do we do with all these different data? So it depends on what comes to us. And we have a whole bunch of processes, both off-the-shelf software and tools that we've built here over the years with funding from NSF to run these large data projects. And part of the NSF requirement over the years has been to make these tools open and distributable. So we're able to leverage these tools for Seabed 2030. We're also able to help people around the world access and use these tools if they're interested in doing that. So that's been a wonderful addition to this project. So depending on what kind of data comes to us, we review it or massage it in various ways. And effectively, we're stacking all these different layers based on some sort of a prioritization score that's based on the quality. And we use that to generate these regional products. So we're generating both the digital elevation model and what we call a TID, which is a type identifier, which tells you what kind of data was used for the depth measurement for a particular grid cell. So those different colors in that bottom panel indicate predicted bathymetry versus multibeam versus seismic, all those different data types I just showed you. So you could use that to pick apart this grid if you wanted. But ultimately, this is really a puzzle, very complicated puzzle. But once again, or furthering the analogy to a puzzle, when you have all these many little pieces, if you can put together some coherent areas, that's how you start to put together the whole puzzle. So I mentioned before the IHO Data Center for Digital Bathymetry. It is the world reference for raw bathymetry. And one of the exciting things that we're doing in the context of this project is we are increasing the holdings of publicly available data in the IHO DCDB. So the data that comes in, if it can go there, it becomes available to the world. It doesn't only go into the JEBCO products, but it can go into any of these other uses, whether it's hydrographic offices, various scientific uses, international agencies, whatever it might be. That raw data archive is a global public resource, which is a really wonderful service that's provided. It also ensures that we're future proofing. So as algorithms improve, we'll be able to leverage this raw data, hopefully even more directly with less human input and interaction. So one of the things that the DCDB also offers is this integrated web application. Again, very messy, lots of lines, there's polygons, lots of different colors. But what I wanted to emphasize here is how many countries are listed. So as we continue to proceed through this project, we're not only growing the catalog of data that sits and is preserved within the data center for digital bathymetry, but we're growing this interface or the coverage that's displayed and accessible through this interface from a bunch of other distributed data centers. So some of these data, like the red lines or the purple lines, there might be some overlap with what's in the DCDB, but some of it is not at the DCDB because you wouldn't be able to see it. It would be covered up by the green. So this is a really useful resource. It's another space where we are working as a global community to help enhance the metadata so that we can make better decisions or better informed decisions from what's here, more than just is there a track line or a polygon, but how do we start to put this together in a less manual way and in a more automatic way to answer, do I need to go remap this area, or is it sufficiently mapped for my personal use case or my project's use case? So back to that analogy of the puzzle, we're really fortunate within our region of Seabed 2030 that there are many initiatives underway that are compiling data into these more coherent regional puzzle pieces. I'm going to show you just a few examples here. It's certainly not all of them. And I also want to emphasize that seabed mapping and sort of this global digital elevation model is the baseline that sort of connects all of these things. But as you'll see, or if you're familiar with these projects and interfaces, there's more than just bathymetry that's being handled in these different regional spaces. So Seabed 2030 is helping in some ways uh, to helping people navigate to these additional resources that augment beyond what we're doing with just the bathymetry. So Australia has a program called AusSeabed. We've been working very closely with several different groups in Australia to make sure that we're not processing the same data, make sure that if there's data that we all have access to, that one has processed and the other hasn't, we're connecting those dots. We're trying to make it easier for their data to come into our products and for our products to go into their products. So we're really trying to help optimize things, and we're developing a wonderful partnership with them. It's really great. The European Union has the IMADNet bathymetry synthesis, which is a massive compilation, and it's another great example of many countries in a region coming together and pooling their data and their expertise and resources to build this digital terrain model that benefits all of them. So this is something that we're able to consume as a big piece of the puzzle we're assembling. And it's also something where we and the other projects that I'm highlighting here also can feed into. So again, we're gaining efficiencies. Portugal has a project called CMAP 2030, and they are doing a great job compiling data. Again, we're trying to work together to find efficiencies. They have multiple resolutions of their products available at different water depths, not dissimilar from the Seabed 2030 depth-dependent resolution goals, but another great partner with a huge area of seafloor in our region here in the Atlantic, which is wonderful and a big help. And then the global multi-resolution topography synthesis that we curate here at Lamont that is largely, if not exclusively, but largely focused certainly on the US academic research fleet data. And this builds on many decades of work that have been done here at Lamont. We're processing the data, we're integrating the data, we're making the processed data available. So if you're an expert user, you can come find those process swath files. If you just want the grids or the images, those are readily accessible to people. And again, we have this back and forth. We're contributing into JEBCO, and JEBCO is the base map that is the background of GMRT. And again, just really focusing on fine-tuning efficiency, getting the metadata right, making sure that all the people contributing and working on this are acknowledged for their efforts and their contributions is part of what we're doing all together. So across just the region of the Indian Atlantic Oceans, we have data contributions as of last year, or maybe that's actually as of this year, of over 200 organizations in over 40 countries. So we've really grown this network of people that are coming together and organizations to contribute data, to work with data that they have that is dusty on a shelf, or they don't have the tools and resources, or they just haven't had the time, whatever it might be. We're getting more and more people, more and more of the ocean covered. We're getting, it's really cross-sector, right? And I think it's really important, at least in my mind, to emphasize the success and the value of this partnership. Government and academia has traditionally been the source of a lot of the data that we've been able to bring together in the deep sea and in the global ocean and throughout the ocean, really. But we're getting more and more industry data. We're getting more and more philanthropies involved and the public through crowdsourced bathymetry. So really, we're growing this movement into a much broader community that is, I think, poised not just to accelerate what we're trying to do with ocean mapping, but really we're learning to work together in a way that we haven't had the opportunity to before. So accelerating toward 2030, there are these emerging sensing solutions. I mentioned some of these already, but just to give them a little bit more emphasis, these tools exist, they've been proven, and we're now really thinking about how to get them to scale. And that goes from the uncrewed vessels to the satellite-derived bathymetry, which is I think this year we're going to have a huge amount of satellite-derived bathymetry, really kind of completing the package of where most of it is, for our purposes, we'll have a lot of it covered. Crowdsourced bathymetry has had a lot of attention over the years. It's really starting to pick up more momentum. I think it will have especially significant value in terms of resurveying in shallow waters as things are changing and as there's more and more crowdsourced bathymetry data that might detect the change. But the other really important thing here, and this is maybe something that all of us who are on the call have some power to impact, and that's transit data acquisition. So the US academic research fleet has been doing transit data acquisition pretty routinely for quite a while, and that's a very large source of the data that's in a lot of these global maps. There are hesitancies around the world in different places for different reasons to acquiring transit data. We had a workshop here a couple years ago that really honed in on this as largely a cultural issue, and how can we as a community aspire to address that? So some of the things, and this is not unique to this particular data type, but some of the things over my career that I've heard, like, oh, we don't want to turn on the sensor because if we're not paying attention and the data quality is bad, it's going to make us look bad. Or if we run the sensor, it will damage the sensor, or there's no one to process, whatever it might be. But I think technically, as far as I understand it, there's no huge risk in terms of running the systems. And the other wonderful reality is that there's a whole community of people, whether they're funded by Seabed 2030 or just part of the broader community that's working on this big problem, who will process the data. And so collecting the data, if you're there, it's a unique opportunity to collect an observation. This is a hat tip to the origins of Lamont, where the director mandated that all data be collected all the time, as often as possible and everywhere. Like this is a fundamental belief, I think, but also it really helps us accelerate this work. And knowing that people will work with it and that algorithms are going to make it easier to work with and faster, I think hopefully will make it a little bit more common as we move forward. So I just wanted to give a little bit of acknowledgement to what we've also been able to do in the deep sea at high resolution. And this is one of my favorite examples when I worked at Woods Hole as an undergrad in 1994. I remember having conversations with the artist who drew this rendition of what the crest of the East Pacific Rise looked like. And the best information that he had to work with was the description coming from the scientist who'd been looking out the window of Alvin and some photos and some sparse data. And so not too much later, a little bit after I finished my postdoc, this very high resolution bathymetry map on the right, 25 centimeter resolution, really starts to show us the kinds of details at the same kind of scale that previously had only been possible through an artistic rendition. And of course, this is now approaching on 20 years old. So this data is much more easy to acquire, still quite costly, but we can cover larger areas and have this kind of incredible detail to help orient ourselves in the deep sea, and do the work that we're doing scientifically at these kinds of sites. This is not necessarily super helpful in terms of filling in the global grid that we're doing, working on within Seabed 2030. But of course, this is, one of the next big steps. How much more of the seafloor can we see at this kind of resolution? I wanted to give a little just plug for the projects here. I mentioned them at the beginning. If you're familiar with any of these projects, or if you're not, these are resources that are out there. It's very much the services that we offer through the Marine Geoscience Data System and the Global Multi-Resolution Topography and GeoMap app all very much complement what's happening within the JEBCO and Seabed 2030 space. These tools provide access to a whole bunch of other data types from ships and submersibles. It's one of many repositories around the world. Again, as we connect more of the people that run these repositories and the resources that are contained in them, these become more accessible to the science community. So if we If you have questions about these or are interested in them, please come and ask us, email us, explore the sites. Um, and just, I think my closing, nope, I have a couple more slides. So I think to close out the topic on ocean mapping, we're really accelerating still. We have a lot more to go. This is another view of what's unmapped, but really with the projection showing it as one ocean. We're making huge progress. This cross-sector international collaboration, coordination, and cooperation, I think, is really critical to what we've achieved so far and what we can achieve in the future. To me, the most important piece that really solidifies this is data, workflow, and knowledge sharing. And I think we are finding new efficiencies and growing capacity. And I'm very excited about accelerating all of that and seeing what we can accomplish together in the future. And then my final thoughts are just to everyone to reach out to those of us that do data stewardship. We're here to support your work. We don't want you to struggle with the systems. They all can be improved. I speak for myself and every other, I think, person that runs these things. We want to hear from you. We want to make things better. Um, and we want you to use the tools. And this last point, I think, is really important that your success really helps to build capacity because every question moves the community forward. So I will stop there and take any questions that you have. Thank you.